Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at algebraic fractions. Now, algebraic fractions are fractions that involve algebra. So the term on the top might be algebraic with a number on the bottom. The both, top and bottom, might be algebraic, or you might have a number divided by something algebraic, okay? Algebraic basically means there is an algebra term in there. So let's look at the example that we'll get onto in a minute. We can see here we've got x squared, we've got x, okay? That makes it an algebraic fraction. You've probably seen this at GCSE, but we're going to cover them again in this video. So on the top here we've got a quadratic. We've got no x term, but it's still a quadratic because you've got the x squared. And on the bottom there, we've got a general quadratic, okay, in the general form. So what can we do to simplify algebraic fractions? That's what we're going to focus on in this lesson. Now, we can simplify algebraic fractions by using division, okay? We can divide top and bottom, and when I say top and bottom, I mean the top and bottom of the fraction. The numerator and the denominator is the technical words, okay? We can divide something by a common factor, because what we're doing is if we've got something on the top and something on the bottom, we can kind of cancel those because they'll cancel each other out. Probably you've seen this before. So let's have a quick look at an example, and then we'll get on to some actual worked examples in a minute. But this is what we want to do. So we want to simplify 5x squared minus 245 divided by 2x squared minus 15x plus 7. Okay, so what I'm going to do is, when we've got quadratics on top and bottom, or just a quadratic on the top, or just on the bottom, wherever, you want to see if you can factorise that quadratic so that we can then use division to help us simplify, okay? So we can factorise here. On the top, we can take out a factor of 5. And on the bottom, let's see whether we can factorise that using our normal factorisation, okay? When we do that, we get this, okay? We've taken our factor of 5 out, leaving us with x squared minus, divide this by 5, it's 49, okay? And then, of course, that's the difference of two squares, so we can write it as two brackets like that, okay? And on the bottom, when you factorise that, it gives you those two brackets there, okay? So now we've factorised. We've got two brackets with a number on the top, and then we've got two brackets on the bottom. Here is where your division can come in really handy, because we've got the same factor of x minus 7 on the top and on the bottom. So what we can do is we can cancel those two out, okay? Because we're multiplying by x minus 7, and then we're dividing also by x minus 7, or some multiple of x minus 7, okay? So we can actually get rid of x minus 7, it cancels out, leaving us with that, okay? And I can actually get rid of that box now. So we have 5 times x minus 7 on the top there, okay? And from this bracket on the bottom, we have 2x minus 1. You could write it with the 5 expanded, okay? But I think it's nicer to factorise out that 5, okay? If we had, let me do this in a blue, if we had this, okay, then we'll be able to factorise, or cancel, sorry, those 5's out, okay? Just leaving us with x plus 7 divided by 2x minus 1. But we don't have the 5 on the bottom, so the 5 has to stay on the top. Okay, let's have a look at some worked examples. Hopefully that rings some bells from GCSEs. We've got 3 examples here, and we're being asked to simplify these fractions. Now, we can see they are algebraic. 1, because that's what the lesson is, and 2, there's lots of algebra on the fractions. So, press pause and have a go, and when you're ready for the answer, press play and we'll work through it. Okay, let's see whether you got part A right. So part A is actually quite simple. All we really have to do is use division. We have to use division for all 3 of these, but using division is only accessible once we've factorised. So we need to factorise, and I'll write this here. Let's factorise what's on the numerator. The numerator is the top of the fraction. So x squared plus 7x plus 12. Okay, and that's quite easy to do. 2 numbers, I'll write it in red, that times to give me 12 and add to give me 7. That is, we'll carry on in red, 1 and 12, 2 and 6, 3 and 4. 1 and 12 does not add to 7, 2 and 6 does not add to 7, but 3 and 4 does add to 7. So when we factorise that, we're going to get x plus 3 times x plus 4, okay? And that then will give us, once expanded, will give us what was on the numerator. So we can rewrite our fraction now, and if we duplicate this down actually, if we duplicate this over here, we can rewrite this fraction as on the top in its factorised form, x plus 3 times x plus 4, and on the bottom we're still going to have x plus 3. Okay, I don't actually have to write brackets around the x plus 3, that's just a decision that I've done, okay, it doesn't really make a difference. So now what we can do is we can do our division, and we can divide top and bottom by x plus 3, okay, they cancel each other out. Divide top and bottom by that, okay, because what we really have is we have x plus 3 divided by x plus 3, and then we've got the times x plus 4. If we bring that x plus 4, this bracket here, if we bring that out, this then clearly gives me 1, okay, so that clearly gives me 1, just to leave me with x plus 4. That's why we can do this cancellation here, okay? So let me just get rid of that, and that leaves us with x plus 4, okay? And then that is our final answer, because we can't do anything more with the term x plus 4, okay? So really quite nice that we've gone from a fraction that had a quadratic divided by a linear term. The quadratic was not factorised, but we were able to factorise it, do some cancellation, just to leave us with x plus 4, okay? I think that's quite a good skill to have. So let's have a look at B. B is a little bit different. We have a quadratic on the top, and then we have a quadratic on the bottom, but in factorised form. So again, we want to do some cancellation, so let's see if we can factorise the top, okay? Factorising the top, or factorising the quadratic on the numerator, we should really say, factorise 2x squared plus 11x plus 12, okay? When we do that, we get this, okay? We get 2x plus 3 times x plus 4, okay? That's what we get there. Now we factorise in the exact same way we did over here, apart from we just multiply the 2 and the 12 together to give us the two numbers that we want to times, okay? So two numbers that times to give me 24 and add to give me 11. We've done that in a previous video, so hopefully by now you should be able to factorise to give me that, okay? So then let's put that back on to our fraction. So if we bring this down here, we can now say our fraction is equal to this. It's equal to 2x plus 3 over x plus 4. And we're dividing that by the factorised quadratic that we were given in the question, okay? And then we can see we've both, on top and bottom, got a factor of x plus 4. So for a similar reason of the previous one, we can cancel that factor out on the top and the bottom. And that then leaves me with 2x plus 3 over x plus 3, okay? And there's nothing more we can really do with that, okay? You could write it in a different way if you wanted to. You could say, and we can maybe add some little arrows in here, you could give that term to the first term and then to the second term, okay? So you could write it like this. 2x being the first term there on the top, 2x divided by x plus 3, and then add the second term, okay? So you could add on 3 divided by x plus 3, because that's how we kind of do addition of fractions. We've got addition here, we are adding those two, so we've got a common denominator, and then we can just maybe write them as a common denominator like that. So you could split up the denominator if you wanted to, but I think that's a much neater way to write things. Part C is a little bit different. We have two quadratics on the top and the bottom, but they are both in general form. They are not factorised. So what we need to do is factorise top and bottom. Okay, now I'm going to take this from the book, I think, or I might not actually have them factorised. No, I don't. So I might have to factorise them here. Okay, let's do that. So we will factorise the top first. So factorise 2x squared minus 5x plus 3. So we need two numbers that times to give me 6 and add to give me minus 5. Okay. Well, that could be 1 and 6. That does not work, and the negatives don't work for that either. Okay, 2 and 3 does not work, but minus 2 and minus 3 does work. Okay, because we can add those together to give me minus 5, and multiplying gives me positive 6. And so we can write that as this. In factorised form, we get 2x minus 2 times 2x minus 3, and then we need to cancel this first bracket down by 2, okay? If you're unsure of how I factorise, there's a previous lesson on that, okay? So we can cancel that first bracket, and I'm going to write the first one like that first to have the 2, and then this second bracket from here is going to be x minus 1, okay? And then when you do the expansion on that, you should get this, which I think you do. Yes, you do. Okay, so that's on the top. We will save that for later. And on the bottom, we have got, and we need to factorise again, we need to factorise 2x squared minus 9x plus 9, okay? So if we factorise that, we need two numbers that times to give me 9, and I'm just going to expand this down here, and that adds to give me minus 9, so 1, and sorry, times to give me 18, not 9, we need to multiply with the 2. Okay, so we need 1 and 18 there, that does not work. 2 and 9 does not work. 3 and 6, they add to give me minus 9, so if we put negatives on both of those, they still times to give me 18, and they add to give me minus 9. So that's what we will use. Okay, we will have 2x minus 3 times 2x minus 6. Okay, and then we can't divide 2x and minus 3 by anything, so that bracket is going to stay the same like that. And the second bracket we can divide by 2 to give me x minus 3. When you expand those brackets, you do get what you need. You get this factorised, or general factorised, not factorised, sorry, general quadratic in the form that we need. Okay, so there is our second factorised quadratic. So putting them then back into the question that we had this set up. Okay, so we had this on the top, and we had this on the bottom. So let me write that. The fraction was this. We had 2x minus 3 times x minus 1 divided by 2x minus 3 times x minus 3. And then of course we can just divide or cancel 2x minus 3 on the numerator and the denominator, and then that leaves us with x minus 1 over x minus 3. And for similar reasons down here, like we did, we could distribute, if you like, the denominator to each term on the numerator. So you could write that, if you wanted to, as x divided by x minus 3 minus 1 over x minus 3. The minus came from the minus with the 1 here. You could write it like that, or you could write it like that. Doesn't matter how you write it. I think it's much neater to write it like that, okay? However, that would be my final answer. That's much more simpler than this setup here, because you've brought these two fractions together because they have a common denominator. Okay, so not too hard there. You've probably seen quite a lot of that at GCSE. Let's have a look at one more example. So this example says we have a fraction is equal to another fraction. So we have 6x squared plus 3x squared. Is that supposed to say 3x squared? Let me double check before I give you that. No, it's supposed to be a cubed. Sorry. There we go. That should be a cubed. Perfect. So we have 6x cubed plus 3x squared minus 84x divided by 6x squared minus 33x plus 44, okay? That is equal to this fraction here. Now to me, this is not factorised, and hopefully you see that as well. There's no factorisation, there's no brackets, we have a cubic and we have a quadratic. Nothing is very simple there. It's still in expanded form or unfactorised form. Here we have a factorisation because I can see I've got brackets, I've got x times something, I've got just a linear on the bottom, so I'm guessing some cancellation has gone on here. A, B and C, this just means are an element of the real numbers. So A, B and C are an element of real numbers. That just means A, B and C are real numbers. Real numbers are the numbers that you can count, you know, 1, 2, 3, any number that is real. So pi's a real number, any integer, any fraction, any decimal, they are all real numbers, okay? What we're being asked to do is we're being asked to find the value of A, B and C. So, pause and have a go, see what you can do. Just ignore for the minute that you're being told that it's equal to this. Just think about what you can do with this. One big hint is to factorise. Once you do that, see whether you can compare it to this form here. So pause and have a go, use that help and then press play and we'll work through the answer. Right, I am first of all going to get rid of the cubic on the top because what I want to do is I want to factorise the top. Now I don't know how to factorise a cubic, so I need to use a little trick. I can see on the top, that's what we've got. Each of those three terms has a factor of x. I could see there's x cubed, there's x squared, and there's x, okay? So I can factorise out of those three terms an x. When I do that, all the powers of x will reduce by 1. So bringing out an x, the x cubed will become an x squared, so we'll have 6x squared. The x squared here is going to reduce power by 1 to give me x, so plus 3x. And then the minus 84x, well I've factorised out the x, so it's going to give me minus 84. And then I can see here in grey, I have got a quadratic. So I'm able to factorise that. Now, I can factorise that the long way if we like, and that's what I did in example 1. But really at A level, we're now getting into bigger questions where the numbers aren't as nice. It's not as simple as just factorise this, okay? So, this is where your calculator comes in really useful. I have the Casio Class Whiz calculator. I think other models do this as well, but your teacher might have told you this, that you can factorise quadratics using your calculator. When you've got big numbers like this, it's really useful to factorise using your calculator. So on my Class Whiz calculator, it's menu A. I'm going to select polynomial and then I'm just going to have degree 2 because that's what our highest degree is. And I'm just going to write in the quadratic that I have. So 6x squared plus 3x minus 84. And maybe you can see that. No, you can't, it's too dark. So all it says is the three terms, and it's the three terms of this quadratic here. When I press equals, I get basically two solutions to the quadratic. So I'm going to write here, using calculator, I get two solutions. I get x is equal to 7 over 2, or I get, pressing the down button, x is equal to minus 4. So that's what the calculator tells me. So how is that useful for factorising? Well, it's really useful actually because I've got two solutions. And those two solutions come from when the two brackets of the factorised form of the quadratic are equal to 0. So, let me write this and explain. That means factorised, we have we have the two brackets 2x minus 7 and x plus 4. Because setting each of those brackets equal to 0 will give me x is equal to 7 over 2 and x is equal to minus 4. So really what we do, if we have a fraction, the bottom number is the coefficient of x and the top number is the number that goes here but with a different sign, so that when we set it equal to 0 we get the correct sign here. And then of course we've just got a number here, so it's going to be x with the opposite sign, so x plus 4. Quick way of factorising, have a look at some other videos on YouTube of how to use your calculator, because I would have been here forever trying to think of numbers that multiply to give me 6 times minus 84 and that add to give me 3. So that's what we do to factorise there. So if I just duplicate this down here, that is the same as x times, and then the two brackets that I've used just to factorise the quadratic in grey. Okay, so I'm going to take that in green because I'm going to use that in a minute, and that's come from that cubic there. Okay, let's have a look at what we could do with the bottom then. So the bottom is a little bit different. It's just a quadratic on the bottom. So factorise again, it's a quadratic, and again it's big numbers. So it's a bit simpler, it's a bit different to what we've just done, but again it's really useful to use your calculator because you can see they are not nice numbers. So again, I'm going to go into menu A, I'm going to select polynomial of degree 2, and then I'm just going to type in what I need. Okay, 6x squared minus 33x plus 42 gives me, it gives me again solutions, but I'm hoping that you can see the solutions that it gives me if I take the solutions and write down the quadratic that it gives me straight away. It gives me that quadratic, okay? It gives me solutions 7 over 2 and 2, so put them into brackets, that's what we get there. Okay, so that is factorised form. All I'm going to do now is I'm going to go back and say, and so the original fraction that we had up here is equal to, and I'll use a different colour there, I will use a blue, this came from there. I will just substitute in here, so we had x, 2x minus 7 times x plus 4 divided by, and we have 2x minus 7 over x minus 2, okay? All I want to do here is now simplify to get it in a form that looks something like this. We have ax times some bracket, and on the bottom just one single bracket, because we could have brackets like that, okay? So what can we do? Well, I could see we can divide top and bottom by x minus 7. They cancel each other out, so that's what we have there. And then if I write that without those two brackets, I have x times x plus 4 divided by x minus 2. And that is in the form that we need. We can see here is my a. Well, we have an invisible 1. There is b. Okay, you can see b is there, the inside the bracket, so 4 is b. And then is it a positive c? It is a positive c, so c must be minus 2. Always take the sign with it, okay? So therefore, we have a must be equal to 1, b must be equal to 4, and c must be equal to minus 2. Those are your values for a, b, and c.